Okay, let us go ahead and get ourselves started again. We have been looking at just parametric elements and changing some of those. I want to talk just real briefly about parametric panels because there's incredible complexity and richness available in that, but it's also kind of really difficult at some level too. Well, I say difficult. That sounds wrong. It's to be respected. There's a lot of work involved in terms of setting those up right, and let's just kind of give you some variations on the theme, but I don't want to spend too much time on that because I want to talk about all these images and the mapping and stuff like that. Okay? The recording has started. See? Thank you. Okay, so panels work amazingly similar, only panels don't just start with a blank field and just no points. Panels start with the notion that there is a grid. There is something at the UV grid, and you go from there. So if you want to go through and say that you're creating a new, say, family. Let's see if I can find where the curtain panels go. Curtain wall panel. Curtain panel pattern base. That's it. You start out with something that looks like this. It's got 4 points for you that are going to represent grid points. Okay. On top of that, we can map a pattern. We'll just leave it rectangular for now. And there's 4 reference lines. And on top of that, we can then start creating different pieces of our panelizing scheme. So by default, there's not a whole lot going on. It's just like a plane there. But if I want to go through and start putting a surface or start putting some sort of tube that runs all the way around and frames it, you can do that. How it works is, in that same sort of way, we have some reference lines connecting these 4 different points. I'm going to draw a circular tube just because that's a good starting point. Circles are always easy. The next thing you learn about circles is that, what is it? They're easy to cheat with because they're sort of omnidirectional, so you get to ignore all the issues about directionality and overlap because circles just, they overlap with each other really nicely. So that's why I often start with them. Okay, so we're going to say draw a circle. I'm going to pick the plane to put it on. I can do it in a number of different places. I'm going to put it on this plane, but it can really be, I think, most any. Let's see if this will work. I pick the plane, then I will go through and do something like that. In the same sense, let me go through and just give that a dimension. So we have a little bit of control. Add a parameter. Let me call this the radius or tube radius. Just kind of try flexing it, just make sure it does what we think it is going to do. Looks pretty good. And now I should be able to hopefully get that profile. And if I want all 4 of the sides, I'll get that whole path and create a form. So now I have this kind of rectangular-y frame of rounded tubes. Very useful for anyone who's thinking about doing a diagrid or something like that, because you can just map that right on top of a grid pattern and hopefully be in pretty good shape. Let me make that a little bit smaller. Now, just for a sense of scale, by default, these grid sections that they're showing are 10 by 10. Don't really worry about that because depending upon how your grid gets mapped out, how your view gets mapped out, those may be 50 by 100. These dimensions you put in, those will be absolute. That tube will be 6 inches in radius or 1 foot in radius. That'll scale, but where those points actually end up just depends on where they get mapped across the surface. Okay, so this is kind of a real simple little panel doing something like this. Now, there's a lot of other little panels that we can create. Some other ones that are sort of useful to know about are, if you go opening, I put a lot of different little panels in here, and we can tell you how they're created. There's the ever popular just extruded panel. Let's take a look at that. It's kind of the simplest thing you can do. The extruded panel looks like this. You can take it out there for right now, and you'll sort of see. basically what happens, how the extruded panel was created, we started with that simple frame that was looking pretty good. We could go through and grab those all, make either a surface or an extruded shape out of it. Yeah. Out of that, I can go through and put some sort of like height to this. In this case, if I wanted to control the height of that extrusion, I could go ahead and put a value in for this positive offset. It looks like that's controlling that already for us. So let's kind of take a look at that. Let's say if it was 3 or 2. Okay. So if I wanted to control it using that variable, I could. Looks like there's also, just kind of hanging off to the side here, some dimensions available for me too. Let's see if I can grab them. Are you on? Okay. I could go ahead and make that dimension. Let's see if that'll work too. I just locked it the way we have been doing it in the past. I call that height. Make an instance parameter out of it. Let's check that out and make sure that works. Okay, looking pretty good. Okay, extruded panel is okay. Extruded panel is wonderful, except for one big problem with it. Extruded panel always extrudes normal, including the corner points normal to the points. So if you have a surface which is, kind of convex, or even concave, same problem. Convex, you'll have gaps between the panels. Concave, you'll have overlaps between the panels, because it doesn't really kind of take into account the difference. Okay, so let me show you an ever so slightly different variation, which may be useful to you. And that is the ever popular seamless panel. The seamless panel is going to look amazingly similar, except to a few of you eagle-eyed folks, you might recognize there's a few more points in this one. Okay, in this one we have not only the placement points, we have these other points which are riding around on top. Okay, let's talk about how they got there. The idea of this one is, as opposed to having the upper points just be an extrusion off the surface, we want them to actually be, it's kind of normal to how the point are extruded off where the point got oriented. So if the point is sort of between two different surfaces, it'll project at the intersection of those two different surfaces. So how that works, just so you get a sense, is take out that surface right there. Okay, I got these two different profiles here. Let me get rid of that one for you and kind of show you how it works. Okay, this looks like our starting point. That looks pretty familiar. If I want to go through and actually have some things that instead of actually being normal to the surface are normal to the placement plane of the point, okay, here's what you got to do. You come on over, you say, hey, I'm going to put some more points in here. And I want to pick what those things should be normal to. So I'm going to come over to this one, and on this point here, I have the choice, do I want it to be relative to, okay, you got the choice, do you want it to be relative to the line or relative to the point? In this case, I want it to be normal to the point. So I'm going to say, it could be off the surface of the point up, could be off the surface to the point to the front, off to the surface to the point in either direction. I'm going to say, the plane is going to be down here. I'm going to put the point right there. Oops, see if I got that right. You pick there. Usually it warns me. Nope, not too complaining. Let's see if it works. I can choose that point. If I choose that point and drag it up, okay, notice it has this neat little variable over here called offset, which is really, really useful to us. That is just the height of that point relative to that point. So let's just kind of test this before we get too excited. We'll say, hey, let's go over there. Let's move this on up. Looks like it moved. Let's move this on down. Super. So I can actually use this point and 3 like it to go through and define the top surface. Okay, and the nice thing is those top surface points will always be some distance off of the bottom there. So I can say, great, that guy over there, let's create a little variable to control that. We can create variables by putting dimensions in, but the easier way is actually to sort of just say that I want to add a parameter. I already had that point height there, so I'm tempted to use it. Okay, and now I can use this parameter height to control that. So if I repeat that operation on all 4 points, okay, let me do it to the second point just so you get a sense of it. Again, I'm going to say point. I'm going to pick which plane it's relative to. It's relative to that one. I'm going to drop it right on top. Then I'll say this other point has an offset equal to height. Okay, now I'm apologizing, I'm going a little fast, but we're going to repeat that for the other two, and just because I want to get to the point about the images, so you can see that. Again, pick off this, got a point on top of there. I'll do another one, pick off of this surface, drop it on top of there. Okay, so I got a couple extra points hanging around. That one, I want to have its offset equal to height also. And this one's offset I want to have equal to height. Okay, got 4 points, looking pretty good. If we have 4 points, we can define a curve, and if we can define 2 curves, we can get a solid, or a surface, or whatever we want in here. So let's go ahead, I'm going to grab some reference lines. I'll let 3D snapping. Hang on, I'm just messing. You. I'm in the wrong plane, I can tell. Let me think about why it's not letting me do that the way I want it to. You, reference line. That's a model line, close enough. Reference line. Okay, now it's snapping. Okay. With those 2 different profiles, I can now grab this profile, including that little piece that I sort of bobbled on, that one, and I can make a form out of there. Okay, and that's how we created the seamless panel. Now, this whole little operation is really incredibly useful. I won't belabor how it goes into it, but some other ones you want to take a look at. I think I showed you the space frame before. It kind of has a lot of interesting geometry going on relative to those 4 points. We took a look at, last time we had the, what was it? It was panel with a resizable opening. That's what we were working at last time. So again, it starts in sort of the same basic way. But you'll see that it's made up of an inner and outer. We got some lines, and the thickness, okay, is really all, it's driven by this opening. So there's an offset that's considered for the opening, and that opening is really what's driving those points around. So if I go through and change the value of the opening to like 0.25, it's moving those around and just reshaping that according to that. Okay, and there's a lot of interesting and weird math that goes on in terms of how to do that and measure them. So I don't want to get bogged down in that because you won't need it for your assignment, but it's good stuff to kind of dig into. Another kind of panel that I wanted to kind of show you that I was working on, that we decided not to give you to work on, is this one. Then kind of flatten it out a little bit better, it might be easier to see. The idea here is to create some shutters that you might put on the outside of a building. And what we want to do here is basically be able to control the shutters, based on, kind of the length so that they overlap, they flip. The idea is you can sort of control those shutters parametrically so they're always oblique to, or normal to the sun, the rays, to kind of control that. And in here, I have a lot of different variables. That's why I decided not to give this one to you, because it really does get a little bit complicated in terms of what it is. But it starts with this notion of really what the angle is. And from that angle, again, whether you want to have a 30-degree angle or a 90-degree angle. Looks like I still have an error back in there. It's a complicated one, or a 120-degree angle. Yep, I still do have an error in it. So it's actually a little bit complicated to control all these different things for all these different angles. But just wanting to, there's incredible flexibility if you want to dig into it. But you don't have to. It's just kind of there for, know that it's available for when you do want to do stuff like that. Okay. Because I worked a long time on this one, and I still got things to do. So it's still not quite right. Another one of my favorites is, I just love my panel with peak. Again, for any of my friends who've been to Singapore, and if you've seen the Esplanade, this is very similar to the they have these little peaked shades, sunshades all over the outside of the glass structure that, again, we can kind of control. And we can go through and control, make that like a 4-foot peak or something like that. A little bit, a very steep peak. Yeah. We can control that again in response to the sun or something like that to go ahead and say how I want it to be. Okay, but we won't deep in on that. I want to talk about images because images are fun. And here's what you need to know about images. Okay, if you can, please go ahead and open up. We'll start a file that already has some stuff set up for us just to make our life a little bit easier. Say no, no, no. Okay, and if you can open up 8.3, which is mapping panels to an image color. Let's talk about what we're going to do. The idea behind it actually is not all that bad in terms of the basic operation. We're going to go ahead and have a surface that we've already divided up into some UVs, and that's okay. We're going to open up a file that already has a surface that's divided up, and we've been doing that a lot. But from that, what we're going to add to it is we're going to go ahead and select an image file, so some picture file, any picture you like. And from the picture file, we're going to use something called read image file to sample color images. And we get to sort of say, what kind of sampling, how many data points do we want? How many data points in the X direction? How many data points in the Y direction? Okay. Then as we go through, and notice my bad spelling, we can go through and take those lists of the color values and do a little bit of rearranging, because what we want to do is make sure that the XY values and the order of the color values as returned from the function are in the same order that the cells on the wall panels are in. So what we're going to do is a little playing around partitioning and transposing the lists, okay, to kind of get them in the right order, and then applying them, just really using the override the element color to actually put that right on the panel. So that sort of makes sense at a high level? It's really sample, kind of take that list of values, do a little juggling that list as necessary to get it into the right order, okay, and then from that, put it on the panels. Okay, so let us see if we can work our way through that. So coming back over to Revit, finish closing up over here. How about this? Oops, got another one here. Open up, if you can, the Revit file. Oh, where did it go? It's under session 8. Let's go through and open up the 8.3. Okay, and you'll see I got a nice surface hanging around over there. It's already been kind of digitized. What we can do, just to kind of give ourselves a clean start, is even go through, if you want to, just take out all those panels. We can regenerate those panels. Okay. And what we're going to do is go over to Dynamo and put them back into that surface. The surface really is here. I'm just hiding it right now. If I say show the surface, that's the surface. Okay. And this could be your surface. This could be the surface that you're creating in the step 1 of the assignment. But we're just going to start with this existing surface that's already kind of hanging around. Okay, let's go over to our land of Dynamo. We'll say add-ins. Within that world, looks like I still have it open, hanging around here. I'm going to open up the example. Dynamo, actually it's still there. Let's close it. I'll get control of this in a while. Okay, we are going to open up the example 8.3. And if you want to, open up the endpoint and we'll back into it. 8.3 end. Let's take a look at this. So this looks like a big old complicated script. In a lot of ways you've seen this before. We have a face. We're going to change that face into our surface into a domain. We're going to divide that up into some UV points. Out of those points, we're going to make some quads. We're going to apply the rectangular seamless panel to the quads. Okay, and ultimately place the adaptive panels. So that part should look pretty straightforward. You've seen that chunk before in terms of all that. We've been doing that, just really running through that whole sequence to kind of do those things. So that's a good starting point, is to go through and do that. We can borrow that code and just kind of use it. What we're going to do is add on to it though. And where it's added onto is up at the top. Let's see if I can find that. Okay, within this, there are a couple sliders we set up for the number of U's and the number of V's. Okay, that's just in terms of how finally we're dividing up the grid. And here's what we're going to do. We're going to go out and grab some sort of image file. And based on that image file, we're going to read that image file. Okay, and use the U and V values, the same U and V values we set up for the grid, to do the sampling of, we basically want one color value for each of the different cells. So if it's 20 by 20, I want 20 by 20, I want 400 points. Okay, or however many, we're going to link that all together. And then out of that, it's going to give us a big old list of colors. From that, we're then going to go through and just start thinking about how it maps. And from that, we might need to do a little partitioning or just rejuggling the data to kind of get it to fit right the way we want it. Okay, so here's what I have in mind. Let's go back to the start file and we'll put it all back together. So 8.3 start. And let's see if we can make this work. Okay, so here's the deal. I already have some nodes set up for the number of U's and V's. That's good. And I need to go ahead and browse on out there and get my badge image or any image you want to use. You go ahead and go grab any image you want. If you have on your machine some sort of photograph or something in just on the Windows machine, some sort of documents, basically go out and browse and see if you can find some sort of file you want to use. And what I did was, oh, hang on. I went to my Dropbox and I found just some nice photos. You just need something. And what do I have here? I'm just going to go ahead and grab, I got this little badge image. You've gotten sick of seeing it. It's it's my smiling face, but it shows up in the corner of Facebook and things like that. Say okay to that. Okay. And we're basically ready now to do something. If I want to, let me go and just run it, and we'll get that image file, and we'll kind of take a look at the image file and what it actually creates. So I'll say run. Let's see if we can make some sense of this. It's doing a little work in the background. The first time it's going to do a lot of work because it's generating all those points, all those adaptive panels kind of hanging around in there. There we go. So there's my smiling face. Hopefully your smiling face looks better than that. You have a path. You have, say, number X, number Y. What that's going to do is basically give us a lot of values. Okay, and what image file does is it returns a whole bunch of color values. And you can do this in terms of either kind of just holding on down and looking at it that way. We could also say, oh, put that watch function in here. Watch is always a really good one. Let's just go ahead and drop it on down in here. Okay, and you can sort of see, here's all these different color values. Now, the cool thing about this list, for better or for worse, is it's a big old flat list. You can see there's 400 of them because it's 20 by 20 right now. But we don't really yet have very much control over how these are mapped out. So if I just go ahead and take these values, these are a bunch of color values, and I feed these color values right into the override element color, okay, let's just sort of see what happens. So I got 400 values in any specific order, or in the order that it sampled it from. I'm going to plug it in here to the override element color. So what's being fed in here is the different elements, okay, the different panel elements, the colors being associated with them right here. Let's go ahead and give it a run and sort of see what it did. So it's going to do a little work in the background here. Looks like it was pretty quick. Either or it's still working. Yep, there it is. Let me go to the top so you can sort of see it a little bit better. Orient this around a little bit. Okay, so see if you can spot the difference here. Okay, here I am, I'm smiling at you. I'm kind of leaning over here to my right, your left. Okay. Here I am, I'm kind of looking at you. I'm doing pretty good in terms of, I'm not flipped upside down, but I'm leaning the other way. Okay, so we got a little issue here in terms of really trying to figure out how this works. Okay, here's the deal. Let's take a moment to go ahead and look at that image file and how the node is actually returning the values that it's sampling from the image file, because this will give us a better sense of really what we need to do to transform that list of color values to have it accurately map onto the surface. Okay, back in Revit. So let me switch to a slightly different example. This is an image where if we were sampling it in 3 different rows, each that had 6 different values. So 6 X values and 3 Y values. This is how the color values are actually returned to us. We're going to have 18 values all together, starting at 0 and going to 17 because it's a 0-based system. And they're going to come from the lower right-hand corner, 0, 1, 2, 3, 4, 5, moving across the lowest row. Values 6, 7, 8, 9, 10, and 11 would be the second row, and 12 through 17 would be the upper row. Now, what we need to do in order to sort of instill some order and ultimately be able to flip or mirror these images is just break that flat list into the rows so we have something to work with in terms of understanding how that data is broken down and what we need to do to start transforming it. So one of the first things we're going to do is actually just break it into a row. And what we're going to do is take those values, okay, and just partition it. And what partitioning does is it takes a number of elements that are part of each grouping within a large list and then just creates subgroupings with that number of elements in it. So in our list of 18, if we partition it by 6, we'll get 3 different rows, each of which has 6 different elements in it. Okay. Once we have those different partitioned sublists, okay, what we can do is then do a transpose. And what a transpose will do is it'll actually take the different elements in the list that correspond. So the first element in the first list, the first element in the second list, and the first element in the third list, and it'll group them together. Okay, so 0, 6, and 12 will come together. 1, 7, and 13 will come together. 2, 8, and 14 will come together. By doing that, what we've established is first what the rows are, and then by doing a transpose, we're figuring out what the columns are. And once we have the column order, then we can go ahead and reverse the order, which will give us that horizontal mirroring. Okay, so let's go ahead and take a look and see how that's implemented. So it all starts over here with our image file. And again, the image file is returning a long flat list. How about this? To go ahead and break it down just a little bit better, kind of the way we were talking about, and reduce the computation time, let me go ahead and make that 6 rows across, or 6 elements across a row, and columns of 3. Okay. Now what we can do is go through and use the partition node. And the partition node is basically going to take our list, so just the contents that have come out of the sampling, okay, and we're going to break it. And again, how we're going to break it is based on the groupings that we want to put together. So if we want to get the rows together, what I'm going to do is get the number of values in the rows, so 6 values across. I'm going to pull that in, okay? And when I go through and run that, and it'll take a little bit to run the first time, what it's going to do is resample the image. It can reduce the number. You can sort of see back over there, I have my little 6 by 3. What we now have is actually 3 different lists. Okay, 3 different lists, each of which contain 6 points. Okay, and that's what we wanted. We have the rows broken out now. So now we can actually go through and try to continue transforming. Now, in terms of what we want to do to flip it or mirror it horizontally, what I want to do is actually take that, but I don't want to sort of rearrange the rows. If I rearrange the rows, that would do a mirror, or they'd flip it vertically. What I want to do is actually transpose it, which will then give us the columns. So I'm going to take that list that had 6 rows of 3, or 6 major lists with 3 points in each of those. Let me run that. And you'll see now what I have is, okay, 6 different lists, as opposed to 3 lists, and each of which have 3 points. So I've just flipped it around. So each of these different lists here corresponds to one of the columns, starting over on the left-hand side, or the right-hand side, excuse me, and moving across the left-hand side. Okay. Now that I have the columns all isolated, I can go through and do this reverse that I keep talking about. And the reverse function just takes a list and it just flips the order. So what's going to happen in this list, which starts with, I'm just going to pull a value out, 158, just so I can sort of spot it from the first point, okay, and 83 from the first point in the last list, okay, and I'm going to reverse it. And when I reverse it, you see it's going to have that first list element is going to be the one that includes the point with 83, and the last one's going to have 158. So what it's just done there is just flipped all the individual rows, excuse me, it's just flipped all the different columns. Okay, got to get that right. It always gets me a little bit confused. Okay, by just going ahead and switching the major order of the list. So it's basically rotated the rightmost column over to the left-hand side, the leftmost column's over on the right-hand side. Now we're almost in good shape, but when it comes time to actually map it back into the surface, we actually have to put things back into the row first, then column order, as opposed to the column first, row order. So what we're going to do is just exactly the opposite. We're going to retranspose it, and when we retranspose it, we're going to take all those values which are now in the right order, okay, but it's going to put them back into lists of 6 different items, so they're back into rows with individual elements within the rows as opposed to the columns. And finally, we're going to go ahead and flatten all that out. And when we run that, you'll see that what happens is it produces a single flat list. But the important thing about our single flat list now is that the columns have been reversed into the right order, so when we map this back to our surface, okay, the colors will get mapped back to the left to right, as opposed to the right to left way in which they've been sampled. Okay, so hopefully that's pretty clear for you. We'll keep on working through examples that you can kind of see how that operates, but that basic notion of taking a grid, kind of going through and slicing it up individual elements by partitioning it and then transposing it as necessary to reorganize the elements and reversing it is kind of a very common element, or a very common operation that we'll continue to use an awful lot. Okay, so what we can do over here is now say, hey, as opposed to the color list, which is just exactly the way it comes off, let's give it this reordered color list. Okay, and as it redoes that, hopefully we'll get some sort of fun in here. Let me hide the mask so we can not see that. Okay, this is a little hard to see there. Let's go ahead and try it, and I'll see if I can make it make more sense. If I say contents, and I just feed the main list to it, you'll see the dark red square is over on this side in the lower left-hand corner. If instead I give it the list that we've just done this mirroring to, it flipped over to the other side. Okay, so this whole notion of just going through and partitioning and then reversing or then like our transposing, that'll give you sort of a flip. And that'll kind of give you the effect you want there. Now, this is not very exciting in terms of this image because it's so grainy right now. If we actually go through and up that to 20 by 20 or something like that, you'll start getting a very, very good looking surface in terms of the image and exactly what it should be mapped to this. So that's the first part in terms of what's going on. Okay, then I think it's step 3 in your assignment or something like that. It's just to kind of take that and read it across. Now, let me go one step further. We'll get to some of the kind of groovy logic to make it happen really quickly next time. But let me go one step further just so you can really dive into the assignment and kind of get started like doing things pretty well. Yeah, get a good start on that. And that would be, let me kind of show you the next example. Oops. Let's go back over here. For the next example, what we really wanted to do is to say, great, once we got the colors, could we actually go through and basically adjust the heights of the panels based on the colors? Okay, so again, we're going to read the color values, we're going to adjust them, okay? But as we're adjusting them, what we're really going to do is say, great, we got the colors in the right order. Can we actually now say, for those colors, just use a color brightness function to give us a value from 0 to 1 based on the brightness of the color, and then go through and use that brightness value to kind of control the height of the panels. Okay, so let's see what that looks like. Come back over here. I will again open Dynamo. Okay, and in here we'll open, come back over here to, there it is, mapping panel heights. Let me go ahead and run this. Let me do it with a slightly smaller number of points just so it doesn't look so big. Okay, so far it's all the same. It's got the UV values, that's all fine. It's going to go through and grab that list. It's going to grab my picture, do all that stuff. It's going to map it on there. Doing a little regeneration here, and that's because I should have showed you the function before I did that. Okay, so I got the image file. I'm doing all the same stuff in terms of this list, but let's go ahead and take it a little bit further. Not only are we going to override the element color, but if we take that list and we actually pump it through something called the color brightness node, we can actually evaluate each of those different colors and just get these different values everywhere from 0 to 1. Okay, and based on that, just put together a formula that'll say, let's go through and based on just the image value that came in, the brightness value, and some sort of amplitude function, just something to say, how we want to scale that value. Anywhere, this will just sort of accentuate the amount of embossing or debossing. Then go through and set the height parameter on the panels, okay, based on that value. Okay, so it's just adding that value in there. Okay, let's show you what the finished effect is. Okay, so now each of these different points not only has kind of a color, but it also has a height that's very specifically set to match the brightness. Okay, and doing that, we can either go through and here I'm just setting it based on that value. If I was going to emboss, I would subtract a value from a plane. If I was going to deboss, I would add the value to a plane just based on when you want the image to go in or out of the surface. Okay, and let's just kind of leave it there for now. This is actually sort of, I'm going to ratchet that up and make it look very accentuated. See if I'd run that. But let's leave it there for now in terms of getting you going. It all starts with just this whole notion of being able to go through and just grab those color values, either kind of map the color or also go through and kind of adjust the heights. Let's run. See what's going on. Yep, it's a little more accentuated. Maybe even in terms of that, we need to do higher still. Okay, let it do its thing. Where we are going to go next time and where you're going to actually sort of finish up this thing is we're going to get to this whole notion of this is pretty good in terms of all these things we're working on, but we'd like a way to reuse some of this stuff. So the idea is for some of these different little strings, like the whole notion of flipping values or mirroring values, that's a pretty good function unto itself. So what we're going to learn is actually how to do something called creating a custom node where we take all this logic and we just plug in some values as inputs. We have a value coming out the back end as an output. And then we just have these reusable chunks, like subroutines that we can then use and share amongst each other, and that you don't have to basically have these gigantic maps. You actually have the ability to kind of have code chunks that can be shared by everybody. Okay, so I guess there's my accentuated image file. But that's the idea you're after. Okay, so let us break for today, and we will resume on Thursday with kind of, looking at this, but then going into that, how we go through and do these modular custom node files to enable us to share the stuff and really kind of work a little more fluidly, as well as we'll talk about Friday how we start iterating things. So we can actually start having little loops to go through and cycle through a lot of values. Okay, great. Let's break. Thank you guys for sticking around.